Well, we're almost done with the course, and one of the last things we like to do is map reading. So if you haven't done so already, I want to remind you, you should have watched the two videos that are before this in the list of videos in the module. So make sure that you've watched the about 15-minute video with a high school teacher teaching his class about how to read a topographic map, and then also the little short one. And you can skip over, he has a long intro and then he tries to sell stuff at the end. But in the middle, he kind of gives you some of the definitions about topographic maps. So we're going to just spend a few minutes making sure that you've got all the information you need about map reading. And then you're going to do a quiz. And part of that quiz is doing a diagram where you're going to figure out the elevation on a map. Okay, so we'll end with that slide. Let's get right to it. Map reading is very important in the fire service. So what's a map? A map is a graphic representation of a portion of the Earth's surface drawn to scale on a plane. Okay, a lot of times we'll draw little maps for a friend that is not to scale, but officially a map should be to scale. That what is on the piece of paper represents what's really there on the earth, and the spaces and everything should be able to guide you from one place to another place. Firefighters usually, generally use two types of maps. There's a third type that we sometimes use that are more for survey use and will show the exact property lines and things of that nature. We use that when doing fire inspections. But the two that we use the most are basic road maps, like the one on the left of your screen. And that's a Thomas Brothers map. Every fire engine used to, some still do, have Thomas Brother maps. In Southern California, it's kind of the standard for accurate maps for roads. But this is just used for navigating. So the road map will get you there. But when you get to a wildland fire, you need a topographic map. And topographic maps are different than road maps in that they show us the lay of the land. And we'll talk about that as we move forward. So the road map might get you there, but the topographic map is going to be best for wildland fires. Topographic maps use basically two scales are the most common. Now, there are other scales out there, but this is what you're going to see the most. And for wildland fires, we're going to use the first one. A 7.5-minute map has a 1 to 24,000 scale. So in English, that's 1 inch equals 2,000 feet. Now, the other type that you do find a lot is a 15-minute map. And if we were in class together, I would have both of these handed out so that you could actually see them, touch them. But because we're doing it online, and you're going to have to look at different ones or maybe see them on the internet. But a 15-minute map has a 1 to 62,000 scale, so 1 inch equals a mile. So these are really good maps, but they're not as detailed as the 7.5. So the 7.5 is what you're going to see most of the time being used by firefighters because it's more detailed, and because it's more close up, it's a little easier to read. Topographic map is so useful in wildland firefighting because of the fact that it gives that graphic three-dimensional representation of the Earth's surface. So we can see the topographic features by knowing how to read a topographic map. The elevation and the land features are indicated by contour lines, and the contour lines, when you know how to read them, will help you know exactly what elevation, but also you can see where's a chimney, where's a ridge line, where's the top of the mountain, where's the stream bed, all of these different things, canyons, a gradual slope, a steep slope. You can read that by looking at a topographic map when you know how to read it. It's more useful because it depicts the terrain and it's more detailed. So in mapping, just a little background here, the Earth is broken up into latitude and longitude, right? So longitude goes from the poles and down. It's the long end of the Earth. That's how I remember it. And latitude is like the equator and the Tropic of Cancer and all of that, all the lines that go around the Earth widthwise. So we use latitude and longitude to give us exact points when we're using maps and reading maps. Now, in colonial America, in the very beginning, they used a lot of different old style ways of surveying the land. And I've read some old land maps, and I have family that came over to America in the very early colonial days with the Puritans who came to Massachusetts and Connecticut and that area. And I've read a couple of the maps, and they say things like, from the old stone to the big oak tree to the this, that belongs to so-and-so. And it was more descriptive. It wasn't using an accurate surveying method that uses latitude and longitude. So in 1785, the public land survey system was established. Now you think about it, who was president in 1785? George Washington. And he had a background in surveying. So that's something a lot of people don't know about George Washington. When he was a farmer, and he was a soldier, and he was a surveyor. So he pushed that we have a survey system. So basically, from the early colonial area east, there's an old system of measuring the land. But from basically the Mississippi or so west, the land is broken up into 1 mile square sections, and they call them sections, and there's townships and ranges and all of this kind of stuff. And it gets a little complicated, but what you need to know is that the topo maps, you're going to see these little red, tiny, very light red lines, and that's the sections that line up with all of this surveying. So when you're reading a map, there's some important things you need to know. Well, first of all, where's north on the map? You have to have that point of reference of north. Most maps, that's going to be the top of the map, but not always, and especially with your GPS, the top of your phone is not always north. That's something you got to remember. I've made that mistake and turned the wrong way because I looked at the map as if the top of it was north. It's not always north. So on most map, north is the top of the map, but it's going to have the compass rose, that compass point where it's going to show you, usually in one of the corners or down at the bottom with the scale, you'll have some kind of an arrow, a star, or the letter N, and it's going to show you which way is north. Now, however, magnetic north and true north are different. So you need to know what they call the declination. And that's shown in the key or scale of the map. So if you look at this little illustration on the left here, Seattle magnetic north is actually 25 degrees east. And New York, magnetic north is actually 20 degrees west of what would show on your compass. So you have to adjust the map to true north based on the declination symbol at the bottom of your map, which we'll see in the next illustration here. So the scale is going to be shown in the graphic scale or the key of the map. And it's usually at the bottom. And oh, you know what? In this one, it doesn't show the exact declination. I'm sorry, but some of them do. It's on a different point than this. So you also find the contour interval in the key or the scale at the bottom of a topographic map. So you can see on that there's the name. And then underneath, it tells us that this is a 7.5 map, a scale of 1 to 24,000. So just to help you, it gives you the scale and how to read the map at the bottom. And you can even use a piece of paper and draw from 0 to the line where it says 1 mile. And you use that to figure out distances on the map. Or there are other ways to read it. There are rulers that help you read in a 1 to 24,000 scale, etc. But look at the very bottom. Then it says contour interval 40 feet. Now, in your first video you watched, you guys talked about, or the teacher talked about, contour interval. So this one is telling us that in a 1 to 24,000 or a 7.5 minute map, the contour interval on this one is going to be 40 feet. So every line represents 40 feet. Then there's usually, and as there is in this one, 5 lines to every contour index line. So 5 times 4 is 20. So 200 feet from every dark line to the next dark line. Okay, those are our contour index lines, and you can see them here. They're darker than the other lines, and those are contour index lines. Okay, let's move forward. We're almost done here already. So elevation, here's some of your definitions, and you want to make sure you've got your study guide out. Let's write these things down. Elevation is defined as the vertical distance a point lies above or below sea level. So we use sea level as our point of reference, just like for direction, north is our point of reference. The sea level is the point of reference for elevation. Now, relief is the definition. It's the difference in elevations in a local area. So relief, in a relief map, they'll actually show it because it's higher and lower, the shape of the terrain or the landform. But with a topo map, we can interpret it when we know how to read it. When we see a whole bunch of V's all together, these lines are in V's, we know that that's a stream bed or some type of a creek bed. So when we see a bunch of U's, we know that that's part of a ridge line, that the U's go away from the top. So V's point to the source of the water. U's work away from the top of the mountain. So a contour line is a line on a map representing an imaginary line on the ground, but that line, everywhere it goes, and it can go on and on and on right off the map into other maps, it's the point of which it's the same elevation. So that line, once it starts, it always represents 2,200 feet or whatever that number might be. So each contour line has a definite elevation assigned to it, and it represents that elevation no matter where it goes on the map. So the difference between those elevations of two adjacent contour lines is the contour interval. Okay, you saw that in the previous video, but I want to review here. Index contour lines, that's spelled wrong, sorry, usually brown or darker. So they have the elevation written on them. Because they don't want to write on every line what that elevation is, it makes the map too busy. They just put the actual elevation numbers on the index contour lines. So if you look at this map, you can see this dark line that moves along here. That's 1,000 feet. This index line over here is 1,200. And if you count, 1, 2, 3, 4, boom, 1,200. So it went from 1,000 to 1,200, and the difference is 200 from index line to index line, but from contour line to contour line, it's 20. So, or 40 feet. Contour interval is 40 feet. So we've got some little indicators. You see how there's V's here, and the V's show a stream bed or a chimney or some type of draw. An M is where two draws meet. See that M there? Here you can see the top of a hill. When you have a circle that has no more circles in it, somewhere within that circle is the very highest point of that mountain or hill. Okay, so let's finish this up. We got just a couple more. Legends are the list of symbols that are used in the maps. So a dirt road has a different symbol than a trail or a paved road. So you look at the legends to make sure you understand that. They're not included with topographic maps from the U.S. Geological Society. No, that's not it. But the administration that does all the maps. I'm just messing up the name there. Geographical, not geological, geographical. So on most topographical maps, they do not have a legend. But you can find them online, or you can purchase them separately. And this bottom left one shows you different like building symbols and things of that nature. So we talked about a key gives you the scale, the legend gives you what the symbols mean. Okay, so that's the way to tell the difference between a legend and a key. So knowing how to read your topo map can save your life. You should be able to see what kind of a contour to the land there is. Is this a steep area? Is it a gradual slope? Do we realize by looking at the map that we're going to be going up in 2,000 feet in elevation in a very short distance? This is steep. So if you read your map right, you can tell what it's going to take to get from one point to another point. Your map is going to tell you what the elevation is, what the contours are, what the land features are, if you read it right. So here this map is showing us there's a stream that's represented. There's roads that are represented. There's structures, little dark squares. The section lines that I talked about earlier are those light red lines. So those, each one represents 1 square mile. So you can find where a chimney is, where a southern aspect is, by just reading your topo map right. It can save your life. Now, what about GPS? Okay, so everybody's saying, well, why do I even need to read this? I got a GPS in my phone. Well, GPS has many drawbacks that you need to be aware of. First of all, it's not going to show you the topographic features that you really need. But hey, GPS needs batteries. And if you run out of your battery, you have no map. If you lose service, which most of these fires are in areas where you don't get service. So again, you're out of luck. Now, if you have a GPS, a Garmin, or one of those that's tied into the satellites, that's helpful. But GPS also can be inaccurate. I've had GPS get me to the wrong place before. So that's a long story, but hey, there's stories of people who've almost driven off cliffs because of GPS. You know, maybe those are old wives' tales, but we've all heard those stories. So they cannot help you plan ahead in regard to elevation and topography. If you're using your topographic maps, you can plan where and when you want to fight the fire using aspect, using elevation, using all of these different things. So make sure you know which part of the GPS is north, because you're not always going to know when you're looking at a phone. GPS has drawbacks. So we're done here, but I want to remind you, be sure to do the assignment and identify the elevation of each of the letters in map A. So this assignment's going to be in there with a quiz, and part of it is going to be reading this map. So it's going to be the one that looks just like this. So let's just do one. Okay, so 5,800 is here, 6,000 is way up here, right? Or 58, yeah, 5,800. 6,000 is right here, and that is, let's see, this line right here. Okay, so this one goes up by 20s. 58, 20, 40, 60, 80, 59. And then this one is 6,000. Is this steep? What do you think? I don't want to climb that. That looks really steep. This does not look steep. So what is A? Do we go down or do we go up? Well, this is 59. This is 6,000. So this is 5780. Point A is 5,760 feet in elevation. Okay? 5,760. I just gave you the first answer. Okay? B is a hard one. I'm going to skip that. G. Okay? If you're in between, this is 5,600. Is the stream going down here, or is it going up here? Oh, it's going up because the V's point up. 5,700, 5,600. So this point on G is between 5,580 and 56. And that's all you have to say. You don't have to be 100% perfect. Somewhere between 5,580 and 5,600 is that elevation. Okay? So you do the rest of them. I gave you A and G. You find the rest. Okay? Good luck on getting your assignment done. This should have been a little shorter than this, but I got talking too much. Sorry. Have a great day. Bye.